Chapter 14, The Behavior of Gases. 14.1, Properties of Gases, including compressibility. Gases are easily compressed because of the space between particles in a gas. Factors affecting gas pressure include amount of gas, volume, and temperature. 14.2, the gas laws. We learned about Boyle's law, pressure and volume. If the temperature is constant, as the pressure of a gas increases, the volume decreases. We also learned about Charles' law, temperature and volume. As the temperature of an enclosed gas increases, the volume increases. If the pressure is constant, then the temperature is constant. We learned about Gay-Lussac's law, pressure and temperature. As the temperature of an enclosed gas increases, the pressure increases if the volume is constant. (14.3) Ideal gases. The ideal gas law. To calculate the number of moles of a contained gas requires an expression that contains the variable n. The ideal gas constant, PV equals nRT. (14.4) Gases, mixtures, and movements. Dalton's law. In a mixture of gases, the total pressure is the sum of the partial pressures of the gases. Graham's law. Gases of lower molar mass diffuse and effuse faster than the gases of higher molar mass. I just like to say, gases are good, gases are great.
Let me kick off chapter 15 with water. Not just water, water. You heard right, water. Water is an amazing liquid that makes plant and animal life possible. Many unique and important properties of water, including its high surface tension and low vapor pressure, result from hydrogen bonding. The structure of ice is a regular open framework of water molecules arranged like a honeycomb. The solution process. As individual solute ions break away from the crystal, the negatively and positively charged ions become surrounded by solvent molecules and the ionic crystal dissolves. Electrolytes and non-electrolytes. All ionic compounds are electrolytes because they dissociate into ions. Hydrates. In writing the formula of a hydrate, use a dot to connect the formula of the compound and number of water molecules per formula unit. A suspension differs from a solution because the particles of suspension are much larger and do not suspend indefinitely. Colloids. Colloids have particles smaller than those in suspensions and larger than those in solutions. Drink some water.
Water. Let's get a holla for Waller.
Everybody raise up your glass and let's toast.
To water.
to water.
I'd like to start chapter 16 off talking about solutions. 16.1 Properties of solutions. Solution formation. The composition of the solvent and the solute determine whether the substance will dissolve. Stirring, parentheses, agitation, parentheses, temperature and surface area of the dissolving particles determine how fast the substance will dissolve. Solubility. Solubility is often expressed in grams of solute per 100 grams of solvent. Factors affecting solubility. Temperature. Pressure. And that's about it. 16.2 Concentrations of solutions, including molarity. To calculate the molarity of a solution, divide the moles of solute by the volume of solution. Making dilutions. Diluting a solution reduces the number of moles of a solute per unit, but the total number of moles of a solute in solution does not change. Percent solutions. The concentration of a solution in percent can be expressed in two ways: as a ratio of the volume of the solute to the volume of the solution, or as the ratio of the mass of the solute to the mass of the solution. (16.3) Properties of solutions. Vapor pressure lowering. Three important colligative properties of solutions are vapor pressure lowering, boiling point elevation, and freezing point depression. Freezing point depression. The magnitude of the freezing point depression is proportional to the number of solute particles dissolved in the solvent and does not depend upon their identity. Boiling point elevation. The magnitude of the boiling point elevation is proportional to the number of solute particles dissolved in the solvent. Y'all. 16.4 Calculations involving colligative properties. Molarity and mole fraction. The unit molality and mole fractions are two additional ways in which chemists express the concentration of a solution. Freezing point depression and boiling point elevation. The magnitudes of the freezing point depression and the boiling point elevation of a solution are directly proportional to the molal concentration when the solute is molecular, not ionic. Now we're done for pressure.
Glad you took the pressure off me.